Alrighty, today I hope to answer a question that we've all felt at one point or another in our lives. Can a Zangief player do basic math? Alright, so, okay, essentially this is the process, right? We do our same value calculations like we did for Cammy in certain sequences. Not individual combos, but sequences. So let's say we have a scenario in which we, as Zangief, find ourselves in a position where we can get crouch short, stand jab, okay? Now we have a couple of options off of here. By default, we need meter to convert off of this, so we can either not convert off of it and just take the space and either poke with stand medium kick, or crouch fierce, or stand, crouch roundhouse, stand fierce, etc. Do something else, whatever. Just take it as is, +4. If we weren't going to spend meter, we would realistically do crouch short, crouch jab because it's +6. And in this instance, it has less pushback. So that would always leave us in a position where, so long as it reaches off of that, we'll always be in a range where we can do crouch roundhouse, etc. But anyway, so let's say, which would do slightly less damage than stand jab, because stand jab does 100 more damage than crouch jab. Sorry, slightly, did I say? I don't know what I just said, whatever. Anyway, so the point is, if we find ourselves in a position where we can do this, there's a couple combo conversions that are available. Most people do that. Whatever. That has its value, that has its damage, its super gain, its whatever. We could also do this. That does slightly less damage, and it builds significantly more super, and it has a slightly closer knockdown, making it easier to follow up with Drive Rush Oki or something. I measure it on the basis of the Stomp route, because I consider the Stomp route to just be better overall, in terms of value calculation. But, theoretically, we could also do this, and then go in for a Drive Rush mix off of the EX Lariat, which we have a number of options off of, depending on the exact distance. We have a meaty. Depending on range, if it's +7, we could link this. If it's +6, we can do that. Or we can do meaty SPD. So, because we get much better Oki off of the EX Lariat than doing this route, in which case we can't get meaty SPD, then I calculate the routes in terms of their value for multiple sequences. So I calculate the value for not converting and just taking the crouch light kick, crouch light punch. I calculate the value for doing the EX Lariat and then doing various sequences, whatever. Drive Rush into a meaty, and the value if it hits, the value if it's blocked, etc. And then Drive Rush into SPD, the value if it's punished, which will depend on the character and the nature of how they punish it, etc. and what resources they have, but whatever. I made a baseless fucking average based on Luke neutral jumping and doing a 3-bar combo, so that's what I did as a baseline assumption. If the SPD just whiffs, but they like jump backwards and they don't punish it, or more realistically, not punished will happen more often, because if they just wake up like EXDP, that'll beat the SPD, but he won't suffer that greatly from it. He'll just take the damage. If they do wake up Drive Reversal, it'll do no damage to him and just knock him backwards a bit. Whatever. So I put the value of not punished roughly here. This could get slightly lower, so realistically it would be less than or equal to that. This one, uncertain, could be greater than, could be less than. On hit, this is the consistent value based on the current measurements, which I may change because I'm still using them with slight modifications from the way I calculated Cammy's value, but Zangief is a very different character, so I could change some of these valuations in the future, whatever, but that would have to, if I changed any of the values, like how much super generation is worth, I'd have to recalculate all of these in terms of their value calculations, and then once we have the value calculations for each sequence, we can move on to statistics. Woo! Statistics! Fuck yeah! I love math! Alright, so then Then we have, okay, well, let's say, in a basic sense, let's say we do the guaranteed damage into shit Oki. So we just do this, right? The drive rush combo into the stomps, into the meter, into the regular lariat, whatever, 3-bar conversion, etc. That's the rough value of that. Now, compare that to doing the less damaging EX lariat into drive rush Oki, alright? Can we calculate what statistics will make it better or worse value than just taking the guaranteed damage with the drive rush combo, drive rush cancel combo? So, the drive rush cancel combo, I measured it in terms of value per drive gauge, which comes out to this. The EX lariat route, if you do the SPD and it whiffs, it comes out to roughly this or less. So less than or equal to 178. If we come in here with if you get punished, less than or greater than equal to -1083, and if the SPD lands, 1735 value per drive gauge if that routing plus the SPD lands. So, then we calculate. So, a basic calculation, if we want to have like 2 options, right? If we want to have, here, I'm actually going to record this in a different way. Alrighty, so this is how it would work. So let's say we have 2 scenarios. A, which is a guarantee, so 100% or 1 times 10 value, which means that if we have B and it happens 50% of the time, or 0.5 times 60 value, then it is statistically more valuable to choose B because A, the estimate would be 10, so 10 times 1, versus B, which would be 0.5 times 60, which would be 30, and 30 is greater than 10, so greater than whatever. Alright, so that means that if we have A, which is a guarantee, and then B, which is not a guarantee, we have to figure out what will make B greater than A. So X times 60. So 10 equals 60X, divide by 60, divide by 60, X equals 1/6, which should be equal to 1.6 infinitely, or 0.16 versus 0.17. So that means that X, so B, the one that is not guaranteed but is worth 6 times more than the one that is guaranteed, is worth it so long as it works out 17% of the time or more. So if you do like a 50-50 in a game and you get it like 50% of the time and it's worth 6 times more than doing the route that's not that's guaranteed or something, that means that yeah, that works out. Now, let's say we have A, which is the guaranteed route. B is, let's say, EX Lariat, Drive Rush, SPD, and it hits. C, which is Drive Rush, Lariat, and it whiffs and you get punished. So let's say -40. And then D, the SPD whiffs, they jump out or they backdash, but they do not punish it, or they like EX SPD it, or wake up drive reversal and hit it, and it doesn't work out, but you don't suffer a huge negative from it. So let's say it's roughly like 3. So that means, where's my fucking drink? I brought a drink in here, I'm sure of it. There it is. That. Yeah, I'm sorry, I need it, I'm an addict. Okay, so, the first simple option is, let's say the only scenarios that can occur, the only scenarios are the SPD hits, or it misses and we get heavily punished for it. Let's say those are the only 2 scenarios, okay? So that means that these values are all accurate, but also B plus C equals 1. Because whatever percentage they are, it will add up to 100% if those are the only two possible outcomes. So these are our two equations, okay? So then we can solve for whether or not it's greater than that. So that means that A is equal to x 60, so xb, well, okay, let me just write the formula first. A, which is a guarantee, so 1a is equal to xb plus yc, and that is our equation. So these are our two equations. This, I meant to do, wait, no, yeah, and this. So we have A, so that's easy. So 10 is equal to 60x minus 40y, and then we solve for y. So that comes out to 40y is equal to 60x minus 10, blah, blah, divided by 40, divided by 40. So y is equal to 6 divided by 4, so 1.5x minus 0.25, and then we solve for this. So we had b plus c equals 1, or rather x plus y, because b and c are the values, not the rates, not the statistics. So x plus y is equal to 1, so that means that y is equal to 1 minus x. So we substitute y here, so 1 minus x is equal to 1.5x minus 0.25 plus x plus 0.25 plus 0.25, so that means 1.25 is equal to 2.5x divided by 2.5 divided by 2.5. 1.25 divided by 2.5 is equal to 0.5, so that results in 0.5 equals x, and x plus y equals 1, so y is also equal to 0.5, so that is where it comes out. So at these valuations, A is equal to 10, and it's guaranteed. B is if the SPD lands, and it's 60. C is if the SPD whiffs, and it gets punished, minus 40. With these statistics, doing the SPD route is worth it 50% of the time. It is worth it so long as the value for x is equal to or greater than or equal to 0.5. So if you can land your SPD 50% of the time or greater with these values, it is statistically more valuable than the guaranteed route. All right, but let's add another dimension, and this is where the math gets more complicated. Right, so D, okay, this is if this is a third theoretical option, and every single theoretical option that we add will make the math infinitely more complicated. So D, so this is like this most oversimplified version, and it's the easiest with SPD because it either hits or it doesn't most of the time. It's not like, oh, you do this meaty, and if it lands, if they jump out or backdash or something, it hits really hard. But if it's blocked, or what if it's perfect parried, what if it's DP'd, what if it's whatever, there's a lot of theoretical options. If it's plus on block, then you do your next option. Do you do SPD? Do you do a meaty? Is that perfect parried? Whatever. Fuck off. So the point is, this is not a complete calculation. Like the SPD could hit counter hit, it could hit punish counter, which would affect the damage and the drive gauge damage, etc. It could whiff in a way that's the damage from getting punished for the SPD is totally inconsistent across the cast and the player that you're playing against, and how prepared they are, what punish they do to the SPD. This also depends on the range that you do an SPD at, because if you do it point blank and they neutral jump, their punish options, depending on their character, might be greater than if you do a max range light SPD and they neutral jump, and maybe their jump in barely reaches and they have to pick a longer button to reach you that is less optimal or something. Whatever. There's a lot of... So this is a super inconsistent. value for C. And these are not the real values, I'm just using it as an example, right? And then D is the value of what if your SPD whiffs, but nothing really bad happens, they just jump back and they don't punish it, it just returns to neutral, etc. Whatever. So, that would mean that A is equal to XB plus YC plus ZD, okay? That's the calculation, and it also means that X plus Y plus Z is equal to 1. For, if these are the 3 potential options, they all add up to 100%. So we have 3 variables, but 2 equations. So that means that we have to solve for one of these to be a dynamic variable, and we would end up with like a sort of bar graph that I'm not gonna fucking show, but... Fucking... Yikes. The fuck is this? Yeah, scatter plot, that's... Oh, yeah. Oh, yeah, factor of x squared to y. That's not even fucking relevant. That's not even what I'm looking at. Oh, fuck, yeah. Oh, this is what I live for. Anyways, the point is that let's say we get 10 is equal to 60x minus 40y plus 3z, and we are going to try to remove z, which means we're going to solve for y and we're going to solve for x, okay? So, actually, alright, it doesn't matter. It doesn't matter which one you solve for, but whatever. So, that would mean that we have to create an equation that can cancel out the existence of one of these variables. So we also have the x plus y plus z equals 1. So if we're going to cancel out y and solve for x, we need to multiply this equation by 40. So 40x plus 40y plus 40z equals 40. And then we can combine these together. We can add these equations together, which means we get 40 plus 10, so we get 50 is equal to 100x, so 60 plus 40x, no y, because minus 40y plus 40y, so we delete y, and that allows us to solve this easier, and then plus 43z, and then we solve for x, so 100x equals 43z, or negative, well, equals 50 minus, or negative 43z plus 50 is the proper way to write that, rather, and then divide by 100, whatever, blah, blah, blah. Fucking math. So x is equal to 43 divided by 100 is obviously equal to negative 0. I don't even know why I put that into the calculator. Plus 50 divided by 2 is 0.5, so that's our equation, and then we replace z with some other variable, so we replace z with alpha. Okay, so that's our equation for x. And honestly, we have enough right there, because if that's our equation for x, then let's say, okay, that's our evaluation, that's the equation we got for the x value. And x is the rate at which the SPD has to land for it to be valuable, right? So, if A is z, so if alpha is z, then alpha is the rate at which the SPD whiffs and nothing particularly bad happens. So let's say that the SPD whiffs, but nothing particularly bad happens 30% of the time. Let's say if alpha equals 0.3, then what values for x and y does that come out to? So that means 0.3 times 0.43. So that would mean x is equal to negative 0.129 or 13. I'm always going to round to the hundredth for these. Plus 0.5, so plus 0.5. So that means x is equal to 0.63. So that's our result. So if z, the rate at which the SPD just whiffs and we either get drive reversal, knockback, whatever, fucking doesn't matter, that means that if our SPD lands 63% of the time or greater, plus the 30%, so that would result in like a 0.2 whatever percent. Wait, yeah. So 0.63 plus 0.3, so that would result in only 0.7%. So that's, in terms of this calculation, that's how that would come out to. So that would mean that our SPD would have to land with this valuation 63% of the time, and we would have to get heavily punished for our SPD only 7% of the time. So with these values, okay, the theoretical values of these possible scenarios unfolding, that's the statistic, that's how likely it has to be, and then we can substitute that with actual match footage, which is not necessarily the most useful thing, but let's say that with conditioning, and you don't always go for the SPD, whatever, and you go for it when you're confident, then, you know, you can probably land, like, I would say 60-70% of your SPDs, and then another fraction of them are just going to whiff and not get punished, and then some of them are going to be heavily punished. The actual values for the SPD are obviously different than this, and they're also dependent on other factors and stuff, and they can be theoretically greater or lesser to degrees that are maybe comparable to the rates at which the, like getting EXDP'd on Wake Up, or the potential punish from various characters could be theoretically greater or lesser, and it's hard to say which one of those is more significant and how they sway one way or the other, but overall, that is how we would calculate these statistics for evaluating what is more valuable, what action is more valuable than another based on their statistical likelihood to occur. If part of it revolves around a gamble or a guessing OK situation or pressure situation, etc. That is how we would calculate these routes to figure out what makes sense for Zangief, and then we'll have to see what the actual statistics unfold for how likely these things are to occur. And then we would substitute all these bullshit fake values for their real values. I say real, quote-unquote, but the calculated values based on my existing methodology that I used in the Cami video, etc. And that's how we would figure this shit out. Alright, so this is how we break it down, right? So we come through here, we have our routes, we have our whatever. Okay, these various options, things, and then we measure out. Initially, I was doing like this weird layered shit where I painstakingly measured the actual sequences because I was worried about drive gauge penalty, so I didn't think I could measure things in isolation from each other in sequences. But then, logically, I realized that if I take them in isolation, you can get something that is not... you can measure something when not under a drive gauge penalty, and then measure something after... measure a lingering drive gauge penalty from any particular action, and then you can separate them, and then when you meld them together, it'll add out anyways. So the extra surplus will be canceled out by the extra lingering effect anyways, and you can make it an additive situation instead of doing all this fucking sequencing stuff. Whatever. So, yeah, right, so then we just measure... Now, in theory, right, we have our sequences, we have our, like, 5 theoretical events, so... Okay, so there's a couple instances. Let's say there's 3 potential options. So if we take an individual action as our player, that it being an SPD in a certain situation, there's a multitude, but we can sort of, for the sake of math, we can simplify it down to 3 potential actions. Something mildly bad happens, or SPD hits, something mildly bad happens, like they jump out, they DP, whatever, or they like full-on fucking punish it. And we can measure those as the 3 potential options. How bad they would be or how good they would be for us if the SPD hits. We can measure out the values of each of these scenarios to a rough equivalent. It's obviously, in that scenario, it's going to be very, very dependent on other factors. But in like an average of a worst case scenario of the opponent doing optimal combos from a neutral jump punish on the SPD, etc., then we can measure out what the actual, get an estimate of what those value propositions will be for scenarios A, B, and C, and then we can measure what statistical likelihood we need for getting a positive value. In this instance, the only positive outcome would be the SPD landing, so we only solve for X out of X, Y, and Z for the statistics of the scenario's likelihood, and we figure out what X is, and if X is at or above 50%, or sorry, if X is at or below 50%, then that's the minimum value necessary for it to result in a statistically positive outcome. So we add in, if there's a scenario with multiple outcomes, for instance, let's say we do this. We do that, and then if the opponent blocks, then we do an SPD. So that is 5 theoretical outcomes. So off of this sequence, it's theoretical outcome 1, this lands, and we just get a full combo. We just combo off of it, right? Theoretical outcome 1. Theoretical outcome 2, he DPs, whatever. He DPs on the wake up, or he does wake up drive reversal, we just get knocked back. Theoretical outcome 3, it's blocked, but outcome 3 is then another sequence that leads into potential options. Let's say if it's blocked, then we are guaranteed to do SPD afterwards, so then we have an additional 3 theoretical outcomes. SPD hits, SPD is like whatever, or whiffs, or SPD is heavily punished. So option 3 of the knee getting blocked transforms into 3 additional outcomes, which means that we actually have 5 outcomes. Knee hits, knee is DP'd, or SPD hits, SPD whiffs, SPD punish. So that means we have an equation with 5 variables, X, Y, and then Z turns into P, Q, and R. Because Z is the likelihood of P, Q, and R together. Now, the thing about math and algebra and such like this is that in order to narrow down equations with multiple variables, in order to actually eliminate variables, you need additional equations. So what equations can we have? We can have the basic outcome that we're trying to get, which is the statistical likelihood. We're looking for specifically X and P, because those are the ones that will be positive. The knee hits by itself because they held up, or they blocked, and then we land an SPD afterwards. So those are the positive outcomes, so we're looking for X and P in that instance. We know that the statistical likelihood of all the outcomes together has to equal 100%, so X plus Y plus P plus Q plus R is equal to 1, so that's 2 equations. We have 5 variables, and we have 2 equations. Now, in an abstract sense, we actually have 6 variables, because Z is also P, Q, and R. So we can turn it into 6 variables to get an extra 2 equations. So we can get, so if we have 6 variables, we need 6 equations in order to eliminate enough variables. So we have P plus PQ plus R is equal to Z. That's a 3rd equation. This is not an equation, this is just for notes. Then we start having to make some baseless assumptions. We have to make just some broad assumptions that seem reasonable enough to be acceptable. Otherwise, we would end up with some weird fucking 3D graph that doesn't really help us. So, assumption number 1. We're going to assume that the rate that we get DP'd or the opponent back jumps our SPD is 4 times more likely than the opponent landing a big optimal combo on it. So the rate at which they DP, the rate at which they fucking back jump but don't punish, or just get like a back jump fireball or something, whatever, okay? The rate at which a disaster happens is 4 times less likely than just it not being successful. Next assumption, we assume that the rate at which the opponent holds up on the Drive Rush Oki is about the same likelihood as the opponent just doing an EXDP on Wake Up. So, generally speaking, I think that's reasonable. You might, maybe I would change it to DP being more likely or less likely than it, but I think they're going to be similar, and that the most likely outcome off of an EX Lariat knockdown into Drive Rush, the most frequent outcome will be the opponent blocks on Wake Up. Why? Because it's kind of awkward to input a meaty SPD in this circumstance. You can absolutely do it, but it requires a more advanced technique. A more advanced technique than just inputting it. So you can do that, and you have to execute it correctly and time it correctly. And that's not statistically... We could only land medium SPD in that circumstance, so even then, on our end, it's not as statistically valuable for us as just getting our forward medium kick knee blocked +4, and then we can do heavy SPD, which will reward us more, both for the block stun and for the extra time cut out from the drive gauge penalty, and from the extra damage of the heavy SPD as compared to the medium SPD. Anyway, so... whatever. Basically, I'm assuming, and then I assume this. I just assume basic flat rate. I just make an assumption. I say the likelihood that they block the knee is about 65%. And that gives us all 6 of our equations that we need to eliminate the 6 variables so that we can figure out X and P. So then we come out to this. So under this circumstance, X comes out to 0.175 or 0.8. P comes out to 0.17. So, under these assumptions, which I feel are reasonable assumptions to make, the knee has to land about 18% of the time for this to be statistically worthwhile, and the SPD after the block knee has to land only about 17% of the time or greater for it to be statistically worthwhile, which means positive outcomes occurring together 35% of the time. If there is a positive outcome out of this mix-up, then this is more valuable. Doing the EX Lariat is more valuable than doing a combo just with a Drive Rush cancel. So that's what we come to, and if we wind up with, you know, as it says, if the potential positive outcomes for a reset or for a less optimal conversion that leads to better Oki, etc., if the statistical likelihood of it being more valuable, if the likelihood of it occurring to make it more valuable is less than or equal to 50%, then basic logic suggests that it is statistically more valuable. It is statistically more likely to occur and generate more value. And I don't think that we need to just aim for 50%. I think that there's lots of instances where, especially in SPDs, if you condition the opponent enough, you can land your SPDs with a above 50% rate if you choose, obviously, when to do them. I think you can raise that, reasonably speaking, up to around 65-70% on certain things. I'm just pulling those numbers out of my ass, but I think you can probably raise that up to like 65% or 70% and still find it to be a more valuable, worthwhile route than just doing the true combo that you're guaranteed to get under these circumstances. So that is my methodology. That's how I'm measuring certain conversions with sequences, and a lot of them yield surprising results, right? So obviously people constantly just do like that as a conversion. I think that's bullshit. EX Lariat is better. EX Lariat is better by a decent degree, but you know what's even better than that? Drive Rush, Crouch Jab, nothing. Alright, landing this is kind of shitty. Landing EX Lariat, especially if you get the 2 hits, significantly better because of the statistical likelihood. You do not have to guess right that often for it to still be more worthwhile. But by far and away, the best outcome, statistically speaking, is this. Now, this has less corner carry. Maybe if I measured corner carry at a different rate, this would be different. I don't think that's the case. But, in any case, this reset scenario is so much better than the EX Lariat Oki, than whatever. Okay, this reset scenario, you are plus 10, the threat of landing this to catch them jumping out, the conversion that you get, huge. If it's blocked, the mix that you get, huge value, plus 4, still in heavy SPD range, lots of other options you can go for, or, especially if you're very close to the opponent, at plus 10, you can do suplex mix, and suplex is, in many ways, overall more valuable than landing SPD. You get much more super gain, you regenerate more drive gauge, and you get much, much, much better Oki off of suplex than SPD. And there's a number of other scenarios you can do with the plus 10 and the extra closeness that you get from doing this as opposed to doing a knockdown. There's also an unspoken value now in Season 2 of doing standing resets with Zangief, because if you're fighting an opponent that doesn't have a natural EXDP, then obviously if you give them a knockdown, they have the option of doing wake up, drive reversal. If they're standing reset, then they can't do that. So anyways, let me actually demonstrate. So, for instance, one thing you might be surprised about from the outcomes, oh, you get a counter hit, like, standing light kick, or punish counter or counter hit standing light kick, you whiff punish, you come in, you do this conversion, right? Okay, but normal Lariat is so fucking bad in terms of giving you any setup, in terms of whatever, in terms of the potential for greater damage after the fact, and even in terms of potential drive gauge regeneration after the fact, that it is actually still, you do not have to guess right with a great degree of frequency to make just standing light kick, punish counter, drive rush, crouch jab still the better option. Now, in this circumstance, you would have to be correct on suplex about 50% of the time or more for it to be statistically more valuable, and you would have to be correct on the headbutt about like 40% of the time or more for it to be statistically more valuable, I think. Actually, I think it's 35. Actually, I can just check. I wrote it all down. Alright, this outcome, 55% for suplex, yeah, 35% for forward heavy punch. 35% of the time it hits the opponent trying to jump out or mash buttons or something. For it to be the worthwhile route to do. That is not including... That is like making a sort of baseline assumption for the value of the mix off the plus 4 on block that you get from forward heavy punch after the fact. Whatever. Now, for some of these other ones, so that's off of a situation where you could get a full medium punch lariat, okay? If you're in a situation where you can only get, like, some bullshit like this, right? The reset is so fucking good. Statistically speaking, it's so good. Alright, let me demonstrate. If you just land, like, crouch short, stand jab, right? And you're in the range, like, let's say you're not there, but, like, let's say you're here, right? And you can either land headbutt or SPD afterwards. You're not quite close enough for suplex. Whatever. Okay, off of those statistics... Oh, fuck. You come out to... The overall value of just doing, like, the drive rush combo route relative to your drive gauge comes out to about this. Versus, like, if you can land... Okay, so suplex is different, but still, if you were to do SPD, it would be around, like, slightly below 50%, which is great. The rating on this for forward heavy punch, 6%. This comes out statistically in an overall value calculation. Forward heavy punch would only have to land on hit from the opponent mashing buttons or trying to jump out off of this situation 6% of the time for it to still be more valuable in the long run than just doing a normal combo off of the drive rush. So, this is how we use math to succeed. And there's some things that I'm going to adjust. I'm gonna have to make adjustments to super measurement, drive gauge measurement, probably corner carry, a lot of these Oki scenarios. And there's a lot of character-specific things, like, for instance, there's lots of characters where landing it close, whatever, and you can jump in a way that if they don't have a frame 1 air invincible DP, they have to hold the jump in, which means that the Oki for just close-range EX Lariat becomes significantly better, etc., so that will adjust some of the Oki routings. Lots of things to consider on a character-by-character basis. But overall, this is our fucking serenity prayer, okay? This is how we use statistics in our value calculations that we're already doing, to unfurl what makes logical sense to do with our routing, with our ideas, whatever.